Okay, we'll try this truss problem here. We have two pins, so we're going to have a force there and a force there, a force there and a force there, we think, to start with anyway. So we want to do ups and downs and lefts and rights and torques and all that fun stuff. We're going to do torques first, so we're going to use this as our reference point right here at A, so we don't have to worry about this one or this one right now. Or this one. We don't have to worry about that one either because that's coming straight on the point. So we have 900. We have 900 times 2 plus 600 times 4. Both of those would be clockwise torques. And that should equal then this force here, which now we know has to be going up because to make it a counterclockwise torque. That force times 2. So we got 1800 plus 2400, 0, to 4200 divided by 2. This force right here is 2100. Now we can do ups equal downs because we know that this is the only one going, this is going up, and that means this thing over here has to actually be going down, so that's a 2100. What about the lefts and the rights? Well, right here is an interesting one because there's only one other member going this way. And this has to be going up. It has to be 2100. So we actually know what this right in here is. This is 2100. And it's a tension, so it'd be a plus 2100. And therefore there's nothing to balance this thing out over here. So this thing has to be a 0 over here, so that we're not actually going to have that one right there. Okay, now that actually then helps us to know what this one is over here. This one has to be going in, and it has to be 1500 because it needs to balance out the 600 and the 900 over here on the other side. Okay, all right, that wasn't too bad. Okay, let's see, where should we go next? Kind of tricky stuff here. Let's go up here to the top. We have a 600 coming into the left, or the right, and so we have this DC member. We know that this DC member needs to be going like up and over, and we know that this has to be 600 because it needs to balance that out. So what we need here is we need an angle in here. Let's do this angle here. This angle here, the opposite of this angle here would be 2 meters over 4 meters, so that's 2 over 4 is 0.5. Inverse tangent, we get a 26.6. And if I do 90 minus 26.6, 90 minus 26.6, 90 minus 26.6 gives me like a 63.4. And we can then figure out this side over here. This side right here. So tangent of 63.4 tangent times 600 would give me this side over here about like 1198. I'm rounding it a little bit, but that's okay. 1198. Okay, and so that means this 600 is balancing out this. So what's this doing? Well, this here has to be equal to the 1198 then, and it's a tension coming out, so this is a plus 1198 right there, so we know what that is. We can do Pythagorean's theorem on these two things here. Plus 600 squared square root, and this one in here, this would be going up like this, and then it'd be coming down like this, so this is compression. This would be a negative 1340, I think. Negative 1340. Okay. Good. All right. Let's so we know that one. And we know this one. Let's go back down right here to this point here because this is interesting now. We know that we have a 1198 coming up and we have a 2100 going down. They're not equal, right? So if I take 2100 minus 1198, that means I still need a 902 going up. So that means that this one right here, this one here, that needs to be kind of a, a going over the left and going up. And this is 902 going up, because that 902 plus the 1198 gives me this 2100. So I know that's 902. Now this angle right in here is 45 degrees. It's two over and 2 up. So this is 45 degrees, which means this is also 902. And I can do Pythagorean's theorem on this, and I get like a negative, let me just do that one real quick here. 902 squared plus 902 squared square root. I get like a 1276, like a 1276. And this is coming in like this. It's a compression. So this in here is going to be a negative, I can't draw anymore, negative. That right there is a negative 1 to negative 1276. Okay, negative 1276. Let's try this other pen. Does this other pen work better? I don't know, maybe. Okay. So this is kind of interesting here, because now I want to figure out this one in here, in the middle here. Okay, so what do I have? I have 900 going this way, and then this way I have basically 900. I mean, it's 902, but I've been kind of rounding off a little bit. So really, this force and this force are technically really already balanced. So that means this force right here in the middle is 0. Technically, it'd be like 2 or something, but we're just going to call it. For some reason I can't write in there. Okay, so we're going to call that a 0. And if that's a 0, then over here, this is a negative 1340, and this is a 0 coming in here. So basically, almost think of this whole one big member here. So this also is going to be a negative 1340 there also. And I think we have everything calculated. I think we have everything calculated there. So that would be how you would do that problem.